At 9:04 in the morning, NASA lost a spacecraft over Mars. Not because an engine failed, not because a computer crashed, not because anyone broke protocol. NASA lost a $327 million mission because every single person involved did exactly what they were supposed to do. And for weeks after that, some of the smartest engineers on Earth were stuck on a question that made no sense. If nobody made a mistake, then what killed it? By the time they found the answer, the spacecraft was already gone, burned, broken apart, scattered somewhere above the red planet. And the most unsettling part? The warning signs had been there for months. They just looked normal. December 11th, 1998. Cape Canaveral. A Delta II rocket lifted a 630-kilogram spacecraft into deep space. Its name, Mars Climate Orbiter. Its mission sounded simple. Reach Mars, enter orbit, study the atmosphere, track dust storms, measure water vapor, and act as a communication relay for future landers. But simple doesn't exist in deep space. This was a journey of 286 days, across nearly 670 million kilometers. And out there, being off by even 1 degree doesn't mean missing a turn. It means missing an entire planet. Inside the Jet Propulsion Laboratory in California, navigators tracked every movement. Meanwhile, more than 1,500 kilometers away in Colorado, Lockheed Martin engineers monitored spacecraft performance. 2 expert teams, 2 world-class organizations, 1 mission. And for months, everything looked perfect. Telemetry was clean, fuel pressure stable, engine temperatures normal, solar arrays producing around 500 watts, guidance systems all green. The mission was on schedule, confidence was high. Then something small appeared, a trajectory drift. Tiny, barely noticeable. A few kilometers here, a few seconds there. Nothing alarming. Because in deep space navigation, small deviations happen all the time. Solar radiation, thruster variability, sensor noise, every anomaly had an explanation. And every explanation made sense. That was the problem. Months passed. By mid-1999, the spacecraft had already completed multiple trajectory correction maneuvers, each one calculated using complex orbital models, thousands of lines of software, and force measurements precise to decimal places. Some corrections changed velocity by just centimeters per second, numbers so small, humans could barely feel them. But in space, those numbers decide everything. And somewhere inside those calculations, one number was wrong. Not corrupted, not missing, not mistyped. Wrong by design. In Colorado, software calculating thruster performance produced data in pound seconds. In California, navigation software expected Newton seconds. Same numbers, completely different meaning. A conversion factor of 4.45. Small on paper, catastrophic in orbit. And nobody noticed. Not for a day, not for a week, for nearly 10 months. Because the interface documents existed, the procedures existed, the reviews happened, the checklists were completed, and every engineer trusted the system. By September 1999, Mars was no longer a destination. It filled the navigation screens. September 23rd, orbital insertion day, the most dangerous phase of the mission. At 8:41 UTC, final sequence initiated. Solar panels rotated, fuel systems pressurized, orientation adjusted. At 9:0046, the main engine ignited. A burn planned to last 16 minutes and 23 seconds. The plan: pass behind Mars, disappear temporarily, then reappear, captured by gravity. Planned altitude: about 140 to 150 kilometers above the surface. Aggressive, but safe. At least, that's what the calculations said. Then, 9:04, the signal disappeared. No panic. This was expected. Mars itself was blocking communication. So they waited. 20 minutes. Nothing. 30 minutes. Still nothing. An hour. Silence. No telemetry. No carrier signal. No emergency beacon. Nothing. At first, they blamed the antenna. Then interference. then timing, then geometry. Anything but the truth. Because the truth made no sense. The spacecraft had never entered orbit. Instead of passing safely at 140 kilometers, it descended to around 57. Nearly 90 kilometers lower than planned. Low enough to hit the upper atmosphere. Low enough for drag forces to take over. Low enough for a spacecraft designed for vacuum to tear itself apart. In seconds, a mission built over nearly a decade was gone. No explosion, no final message, just silence. Back on Earth, the investigation began. Telemetry logs, navigation models, thruster data, software audits, hundreds of engineers, thousands of pages, until one discovery changed everything. A file. A perfectly valid file. Generated exactly as designed. Containing perfectly accurate data in the wrong units. Pound seconds instead of Newton seconds. One team followed their software. Another team followed their documentation. Both teams followed procedure. Both teams did their jobs. And the spacecraft still died. Official loss: $327 million. One of the most expensive unit conversion failures in history. But the real loss was something deeper, because the investigation revealed something far more dangerous than bad math. The problem wasn't just the unit mismatch. The problem was a system where assumptions were never challenged. Warnings had appeared, anomalies had been noticed, questions had been asked, but every concern had an explanation, and every explanation sounded reasonable, not incompetence. Trust, routine, process. The belief that if every box is checked, the system must be safe. After the failure, NASA changed everything. Interface validation, independent verification, cross-team data audits, strict unit enforcement, not because the math was hard, but because trust, without verification, can destroy spacecraft. Even today, this mission is taught in engineering schools, a story about human error, but as something far more unsettling. Because when someone makes a mistake, you can fix it. When a machine breaks, you can replace it. But when an entire system allows everyone to be right and still produces disaster, failure becomes invisible. And invisible failures are the ones that cost the most. Because they don't look like chaos. They look exactly like success, right up until the signal disappears.